He said that soil without biology is geology. You're supposed to have life in there. So by telling people to use harsh chemical fertilizers, I was part of the problem. And I heard this saying is be the solution, not be the problem.
Welcome to Home Green Homes Podcast. I am Izumi Tanaka, a green home advisor and a green realtor. Here I invite a variety of experts in the world of green homes and have conversations about how we can all live in healthy, resilient, and efficient homes. My guests provide insight in a wide range of topics, from designing, building, and living in green homes, purchasing or financing green homes and improvements, to how we can live to reduce the negative environmental impact from the way we live. My goal is to inspire and inform you about how we can make a difference in our own lives and our environment. Hello everyone, this is Izumi Tanaka with Home Green Homes Podcast. Today I have a guest, Dane Shota, and he is an arborist and horticulturalist, but he has a very special presentation that he's going to share with us. But first, I'm going to ask Dane about who he is and how he got to where he is today. So Dane, thank you so much, first of all, for spending your time with us today. And if you can tell me about who you are and what you do.
Okay, well, I was born in Hawaii and I was transplanted from Hawaii, but I was brought in when I was a baby, so I'm pretty much born in California. And I was really into plants in high school and went to Cal Poly Pomona, graduated there, and they taught me what they taught me. And then a lot of the stuff that I learned was afterwards. I went into houseplants, went into actually selling trees in California. And I was there for about 20 and a half years. I really thought it was pretty interesting on people selling houses, though. That was a large ticket item, and I really looked up to real estate agents. And then later on, I got my real estate license, and then I got my broker's license. And here we are. I help the landscape professionals and nursery guys on selling either a farm or nursery or homes for these people. Mm-hmm. And well, you'll see on the presentation how I got to the rest. So my presentation is rainwater only landscapes. We're using living soil, consulting arborist, and I'm a horticulturalist, graduated Cal Poly Pomona. I'm also a certified water auditor. Okay, I know what.
Can you tell me what that is? Can you tell me what a certified water auditor do?
So what we do is we audit the irrigation after the Model Water Efficiency Landscape Ordinance, which is the state mandated ordinance. And I'll go over that in a longer presentation. However, there's an audit that's needed after you install your landscape under state ordinance.
State meaning California?
California, yes. Okay. And I actually was the speaker for that ordinance. We call it for short MWILO. So some of your professionals will say that. And I taught the soils and the plant part of it for the introduction for the landscape professionals.
I see.
We're in a drought in California. We've had a drought before, and the saying before is the new green is brown, but the new green does not have to be brown. However, xeriscape, me before, really didn't interest me because what was highlighted was cactus. And that was just not my style. However, if you do like cactus, then go for it. However, this is what I came up with. I came up with a landscape that attracts bees, butterflies, and hummingbirds. People like color. So I brought in a colorful landscape. I propagated everything except for two plants, which was the salvia, which is the one on the right over here, and this desert museum. And this was actually built for my father-in-law in the late 2016. In 2017, I put in the landscape.
Mm.
And 2018 and on, I didn't irrigate. So we irrigated this for 1 year. And I recommend that you irrigate your plants to make living soil for 1 year and then cut it off. The only plant that I have that is native is this one. The common name is called the butterfly weed. It attracts butterflies. I went to another seminar that gave me the idea of this rainwater only concept. And they said these succulents won't live in rainwater only. However, they weren't working with living soil. This is living soil. This is plants that I had in here when I actually bought my property in Huntington Beach. It's been here. I bought my property in '98. And we can see that this is already established plants. And if I choose to do rainwater only, make it living soil, I can go rainwater only. So even established plants that are drought tolerant, you could change that into living soil and go rainwater only. You may not have to go and change out all your plants. How did we kill our soil? We know that soil compaction is the most common limiting factor in trees growing in urban soils, according to Steve Batchelor and Molly Batchelor. This is in our Western Arborist booklet that comes to us, newsletter. What I use is AMS tools. This is good quality tools. I went to a group of gardeners, a gardeners association, and I thought I was going to teach them something. So I said, who has one of these soil probes? And to my dismay, they all raised their hands. They have this soil probe. And I go, oh my gosh, how did you know about this? They said, John Kabashima, who's an ag advisor, says that you have no business being in this business without the soil probe. We can see how dense the soil is, how hard the soil is by putting this in. We could see how much moisture there is by using this probe. And I went to a job site in Yorba Linda. This landscaper brought me all around the place because I'm charging by the hour, and he's getting me to different places that he's having problems with. And one of them was Yorba Linda, and it was sandy soil in that area. So I went down and I used that soil probe, and I went down and we could feel about 2 feet, we could feel this boom, and the soil actually shook underneath our feet.
Wow.
And I said, what do you think this is? And he says, maybe it's a rock. So I got my soil probe, and this is something that's probably about $500 today with a case. It's a 3-inch stainless steel bucket auger. This is how you are able to use to go down and retrieve soil samples and not contaminate it. Stainless steel bucket auger and about a 4-foot shaft and a ratchet handle. And I'm able to core out that same hole, that little hole that I went through, and it was all sand. And he said, how could that be? And I said, have you ever heard of sandstone? He says, yes. I said, you can compact sand so hard that it becomes stone. Then he understood. How can you get roots to go through sandstone? You cannot go rainwater only unless you soften up your soil. What we need is roots. And for some reason, humans, animals, and plant roots, we like water and oxygen. If you don't have one of those two, life does not go there. So it's hard soil, and the roots are coming up to the top. Soil science rules is that you can't bring down the pH for a long period of time. It will go back to what it was before. It's called buffering capacity. This is traditional soil science rules. And heavy metals cannot be moved. Heavy metals, if it accumulates, it can be toxic. If it's too much heavy metals, microbes will not live. They put copper in marine paint to keep algae from growing on the bottom of the boats. Algae is alive. Phosphorus cannot be moved through the soil profile. Phosphorus is involved with making roots grow and flowers to pop out. What if we can change this? Yeah, we can with living soil. There's something called prescription fertilizer. This is where we take soil tests. The concept is you put in what your soil is lacking in and leave out what your soil is abundant of. It really makes sense. but too much of one element will keep another element from coming up into the plant. However, so I'm telling people to do soil testing. However, Rodale, the founder of Organic Gardening Magazine, saw the relationship between harsh chemical fertilizers killing the microbes back in the mid-1940s. He believed in healthy soils equals healthy plants equals healthy animals equals healthy people. And I was reading this, a while back, but way past when I was graduating, and I'm thinking, where did I miss this? This Gabe Brown, I watched him recently because he has a webinar that's called Regenerative Agriculture. And so I'm in this group now, it's regenerative real estate. And I wanted to know more about what the word regenerative is. It means making new. And he had some dead soil and he made it new. But he said that soil without biology is geology. You're supposed to have life in there. So by telling people to use harsh chemical fertilizers, I was part of the problem. And I heard this saying is be the solution, not be the problem. I'm going to talk to you about harsh chemical fertilizers versus control release fertilizers. This is harsh chemical fertilizers. This is released really fast. Have you ever used this fertilizer? It's pretty exciting. If you do have some microbes in the soil, you throw this on and your maybe lawn would just green up so fast, boom, like that. It's like magic. And but you keep on doing this and eventually your soil dies and then you don't get that reaction anymore. You killed all the microbes. This is actually control release fertilizers. Fertilizers that's released very slowly. And it's actually shown that control release fertilizer will actually feed the microbes. Okay, the one on the right is a 1-year fertilizer that actually has a lot of microbes in here. After you get your soil all fixed, this is something that you could keep it going. And it has more microbes that you can find than what you can find on the nursery shelf. Rules of permaculture. Masanobu Fukuoka, he came up with this no tilling and no digging. It was like a do nothing farming. He was actually able to grow rice without that much water, which I thought was pretty interesting because we need a lot of water today to grow rice.
Yes.
And this happened. He said this after the Dust Bowl. And why we couldn't come up with this here in the US of no tilling, I don't understand. Why did this guy way in the other part of the world have to come up with the no tilling part? When in the 1930s, we had a lot of people that died in Oklahoma. And it wasn't until this dust went all the way to New York City, the politicians said, we have to do something about that. And then they taught them how not to till as much. But Gabe Brown, he said that in Eastern Europe, we had this happen in 2014. We still haven't learned. We're still tilling. We're still screwing up our microbes. Okay. When you till, you disturb your microbes, your earthworms, your life in the soil. This is some healthy soil in the forest on the left, and on the right, this is soil that was tilled right next to it. And you could see the texture has changed. It's dead. This is dead soil. We can till the soil until it's dead. Well, this is soil. Roots have a hard time getting into the soil on the right. There's not that much airspace, but the soil on the left, there is. So we have a lot of microbes on the one on the left and very little on the one on the right. We need to stop tilling. Now, it's not how much you make that counts, it's how much you keep. They even say this about finances, right? But this is for soil. So when it rains, it's not how much you make, how much it rains, it's how much you keep, how much you can hold on to that rainwater. If the rain comes into your soil, you're holding on to all that moisture. Everything goes into that soil. If it doesn't, it goes around the soil and it goes to the side. It goes into our storm drains.
Right.
Okay. We do not have watersheds anymore.
Mm.
Our watersheds are just gone, and watersheds help sink carbon. We need to find out how to create living soil. It's really easy to kill it, but how do we fix it? This is a good book, a good reference book that I found.
Mm-hmm.
And it's a fascinating book, Teeming with Microbes. The first quarter was so fascinating, it was hard to put down. And it talks about a soil food web. We used to have animals before. In fact, if you're watching this webinar and you do see some deer in front of your house and you're not irrigating, this may not be the webinar for you. But for urban areas, we don't see animals around the neighborhood. And we're supposed to have this food web where everything's eating each other. It's life, it's the food web. And microbes will actually live. We have so much nitrogen in the air. Why do we want to go and buy fertilizer? It's free, nitrogen's free. We've got legumes that could bring into the soil nitrogen. We've got nitrogen fixing bacteria. It takes it out of the air and brings it into the ground. So we just need healthy soil. We need living soil. We need living soil that has enough population. Bonnie Bassler was talking at TED Talks, and she said that this Hawaiian bobtail squid will go out and, well, it'll actually in the daytime, it releases bacteria, and in the evening, it starts to bring in all the bacteria inside it. And it's able, with this bacteria, to make itself glow. It's like a Harry Potter cloak, where it actually goes out and then the moonshine would come and the predators can't see it. Okay, so, but you need to have enough concentration to be able to get quorum sensing, the ability for the microbes to interact with each other and bring up nutrients to the plants, and also be able to fight plant pathogens. Also to aggregate the soil. The microbes, especially bacteria, they're able to aggregate soil particles, pull it in, and now water and oxygen can go around the soil. And roots can go inside the soil now. It's got oxygen. So by telling people to use harsh chemical fertilizers, I was part of the problem. That saying, be the solution, not the problem. Now I feel it that I have to go and tell everybody, we need to fix this situation. We need to make living soil. Jerry White was one of my clients, customers that I sold trees to in the past. And I was telling him that I was selling properties and whatnot. And he told me what he did. He made this product that actually fixes soil. And he uses it with biology. He graduated in microbiology at Stanford. He's a third generation nurseryman. There's three generations in that nursery. And he, to be able to have that passion to create something to fix soil. I'm going to do this demonstration for you. This is the groundbreaker. It's a soil penetrant. Now, soil penetrants do not work on all soils. They work on either chemically bound or physically bound soils. Jerry White made one, this one right here, that works on all soils. So it works on every different type of soil. So this is a waterproof barrier, and this is just water. As you can see, this is a waterproof barrier. And this is some soil penetrant here.
Oh, wow.
And you can see it's going right through this barrier. Okay. Some people are asking, how do you get your soil to drain if you can't till? I just proved it. So this is the first part of it. It's called a soil penetrant. So you just spray this down and water in. Now, obviously, that was not soil. However, it works on soil. We need to have microbes and organic matter.
Right.
But this makes our home, where it's a drainage system, where it goes right into the storm drain, an infiltration system so we can actually hold on to the moisture instead of running off and going into the storm drains. Okay, we need to get our soils to drain. So this is what Jerry made, was this garden max, which it has microbes. It's registered as a fertilizer to be able to say it has nutrients in this for 6 years.
I see.
Okay, so let's look at this. It softens hard soil and heavy clay. It aggregates the soil particles. Some people might say, but I have sandy soil. What does that do for me? Well, it does the same thing. It aggregates the soil particles. It brings it in, so now water can be held inside that soil as compared to not being aggregated. And this builds strong roots. The main thing with rainwater only landscapes is you need roots, lots of roots. It needs to be deep, and it corrects the pH. Okay, so let's say, I would say, how does it correct the pH? Let's say if it brings it more towards neutral. If it goes too high, a bacteria will bring it down. If it goes too low, another bacteria will bring it up. It regulates the pH. As in conventional soil science, you can't do that. That's what I brought up. And also we can move heavy metals now. It's easy to apply, no digging. Now, this took me 1 month to get over this because I'm really old school. I learned to dig. I learned to till. In junior high, we took gardening and we grew vegetables and we made rows, we dug. That's what was ingrained into my head. You can get a Phillips screwdriver or one of those soil probes. You could stab the soil, and by the days you could feel it loosening up. The warmer the weather is, the faster it works. In Las Vegas, it's almost like overnight. It's the microbe population just booms, but it gets when it gets hot. And it's pet safe, earth safe. Oh, when the microbes die, it retains the nutrients. So even if the microbe dies, it gets held into the soil. It doesn't go into the water, our groundwater, lakes and streams. It gets held into the soil. Okay, and it's got 10 times more microbes than you can find on the nursery shelf. And the average landscaper says it's about 40% water savings on normal plants. The nitrogen is very little, like 1%, 1% phosphorus, 0.5% potash. If the nitrogen is too high, it affects the root to shoot ratio. If the nitrogen is high, it makes more shoots and less roots. What we need is more roots. Forget about the shoots. We need roots. We need to grow roots to go rainwater only. Forget about the top. The top will come. We need to grow roots. And these are all microbes. Mycorrhizae, that's a fungus, and 2 different types, and then beneficial bacteria. It's proprietary, so there's actually more than this.
Now, Dane, we both live in Southern California where we are experiencing severe drought, obviously.
Yeah.
But does this apply to other areas in the US or even the world where, where they're not having any water issues in terms of the soil?
Yes, because even in different areas, let's say Washington, Oregon, places that they do have rain, when it doesn't rain, they still irrigate.
Right.
Why? If we could do this here in California, why can't they do it over there?
Right.
If we can do that in Arizona, why can't they do it over there?
How about areas like East Coast where they're, like today, where they're getting hammered with water? Yes.
Well, I would say don't irrigate in rain.
That's for sure.
Okay. So we need to get areas that have rain right now to be able to go into the groundwater. So when they do have a drought, they have groundwater.
Right.
California, we're just killing our soils in the Central Valley, and that's where we farm. We need to get that water into the ground. This is Julie Barlow, who's a horticulturalist. She taught me about this garden max, and she put this on soil so that the plants soil gets healthy, so the plants get healthy. This is 9-foot tomato plants in clay soil because it can now drain. Water goes right through it. This is Escondido. And Brandywine Tomatoes is an heirloom variety. It normally doesn't get that much tomatoes. However, she was able to get 25 pounds per plant, and that's a lot. She had to open up a produce stand just to try to get rid of this stuff. 2.3 pounds per each fruit. That's bigger than normal. Broccoli, cauliflower. What's exciting about this is normally you change out your plants every year. This is the same plants that she put in 3 years ago.
Oh, wow. Wow.
The plants still live. New meaning of sustainability. One thing that I see, this Turf Max, I put 3 applications on this Lippia naudiflora, which is, the common name is Carapia. It's a variety from Japan. And so 3 applications of this Turf Max. This Turf Max is actually made for turf. Okay, this plant is what they call a dicot. So turf is grass is a monocot. One leaf pops out of the ground when it first emerges. Dicots are the rest. There are two leaves pop out. So the Teeming with Microbes book says that in turf areas, grasslands, there's more bacteria to fungus ratio. In woodlands, there's more fungus to bacteria ratio. So the Turf Max has more bacteria than the Garden Max does. So this one, with one application, I was able to get this Lippia naudiflora to grow instead of 3 Turf Max. But this has about 3 times, well, this has 3 times the amount of organic matter than the Turf Max does too. But if you want to save labor, you want to make sure that you put the right one on. Downer, an ag advisor, says that beneficial microbes are antibiotics. They'll fight plant pathogens. It's just that beneficial microbes will not live in the urban soil because of the compaction. This is USC. The one on the right is treated. The one on the left is not treated. And it's dying because of a disease. It's either called Phytophthora, verticillium, or dampening off. Those are the ones that can kill a color like this. And when you're selling homes, the color really helps show the property. University of Las Vegas used this product. They had problems with capillary movement. You see the CV12 on the left. It's these drip tubings. And this drip tubing, sometimes in certain soils, it just goes straight down. It doesn't go out. So some of the roots is not being irrigated. And they're able to show that using this Garden Max and the Groundbreaker, the water can go out. Now all the plants can be watered. All the roots can be touched. Okay, so this is supposed to be 12-inch spacing. So this is as per recommendation from the manufacturer, but even we don't see it work on some soils. However, with the Garden Max, we do, and the Groundbreaker. So what's the difference between amendments and this green as get soil treatments like Garden Max, Turf Max? Amendments, you need to dig into the soil. Okay, this Garden Max, Turf Max, you just need to put it right on the top. You don't need to dig it inside there. That's the difference. So these are not considered amendments, it's soil treatments. So one reason why I did this webinar is pretty much to keep people from getting into this artificial grass. This is not going to sink any carbon. In fact, it will kill soil. They put all these inversion layers like I talked about. And how much more plastic do we need? Where are these artificial turf going? It's going into the landfill. And we can actually treat hillside properties. Landscape contractors said that they can save about 40% water savings. And UC Riverside says they come up with the same 40% water savings in grass. What we do is just see roots grow. And I was able to get drought tolerant plants and go rainwater only. We can make our own watersheds and our food web. What we could see is it will clean the air. We can actually have healthy soil that will clean the air, sink carbon. I thought landscapes were sinking carbon. However, it takes energy to go and pump the water out of the hose. This is something in Huntington Beach where it's electric plant with actually fossil fuels. UC Davis says that we can save energy and reduce greenhouse emissions by cutting back on our water. With rainwater only landscapes, can we be good stewards and have no emissions with our landscapes, clean the air, have our own watershed, and save money at the same time? This is a place where you can actually find the products, and a distributor that Green as Gets has goes all the way through the continental US and also Hawaii. And just put down the locator and zip code. And if it's not in your area yet, there's no interest actually around your area yet. But the conclusion is beneficial microbes are antibiotics. They'll fight plant pathogens, but they won't live in compacted soils. Permaculture rules, there's no tilling, no digging. Inversion layers will keep the water from going through the soil profile, accumulate toxic salts, and does not let the roots grow deep. High nitrogen fertilizers changes the root to shoot ratio. To achieve rainwater-only landscapes, you need living soil and drought-tolerant plants. Compaction is the most common limiting factor in urban soils. You need enough micropopulation to achieve quorum sensing for the microbes to be able to work together and do something like aggregate the soil particles or bring up the nutrients. It's not how much that you make, it's how much you can keep.
So those products, can you use it on the existing garden? For instance, I have some trees that are not doing well, some plants that are not doing well. Can you use them and revitalize
Yes,
them?
that's actually what it was made for. Because these products was made to get plants healthy. It was not made to save water.
Right.
It was not made to go rainwater only. That was pretty much my idea.
Very interesting. Well, thank you so much, Dane. It was very fascinating to listen to this. I am, it's still a little bit hard to wrap my brain around it, but listening to you would really inspires me that, okay, we got to really take care of our soil. So thank you so much for your inspiration. Yeah. Right. Thank you so much. This was Izumi Tanaka with Home Green Homes Podcast. Until my next episode.